Hello everybody and welcome back to this new video. Today we're going to be talking about the Linux box red from CyberSecLabs. So in our Nmap scan we'll notice that we have SSH open, we have HTTP open, and we have redis open. Now redis is currently the most interesting thing to check out because that's something you don't see often, and very often redis is left unauthorized or allows unauthenticated users to do stuff. So let's check that out first. So we have port 62379, so we can netcat to the IP 9, and then with the port, and we'll do V for both. Okay. So now what you can try in Redis is do info, and if you see all of this information, you know, okay, we have unauthenticated access. So we also get this version here that Nmap also gave us. So the next thing we could try is do a search exploit for Redis and see if any RCE with that version is possible. So if we do a search exploit for Redis, we'll see, okay, there is this unauthenticated code execution, which has a Metasploit module, which we're not going to use in this video because it's too straightforward and we want to dig a little deeper in how this works. But this is for version 4.x and 5.x. So that would work perfectly. So then if you would research that vulnerability, you would probably come across this PDF from a talk at Zero Nights. And this talks about how you can exploit this Redis to get remote code execution. And the steps pretty much are, we are going to make the server a slave of our rogue server. So we're going to start a server locally, and we are going to make the remote server that we want to take over, that we want to get code execution on, we're going to make that a secondary to our primary. Alright, then we are going to set a database file name. We are then going to, eventually, we want to load a module, and this module is going to be C code, because in Redis you can have modules that are C code, and that's going to execute. We're going to load that on our primary, but because they are the remote server is a secondary to our primary, it's also going to load that module. Now for this module, you can look around. I chose this one, the Redis modules execute command. And this module, when you build it, it's going to allow you to execute system commands, right? So what I did was I pulled this Git repo, and then I typed make to compile the file, and now I have this module.so file, right? So we want to load that on the remote server. Now, to get that RCE, there's this Git repo that does that for us. So I also pulled this, and looking at the files here, we can take a closer look at the code. So it's first of all going to do a lot with arguments, and then it's going to start running the server. So it's going to make a connection. If we have authentication, it's going to authorize, but in our case, we don't need to have any authentication. So then it's going to send the slave off command, and it's going to make the remote a slave of our server. And it's going to set the file name. It's going to start listening. It's going to create a rogue server like locally, and it's going to make sure that the rogue server listens for incoming connections, and it's then going to make the remote server connect to us. Then it can load the module. It's going to then remove the slave from the remote server, so we don't have any secondaries anymore. And then I'm going to close our server, and then we have remote code execution. So then we can, for example, interact, and our interaction is going to allow us to get a reverse shell, or in this case, it's going to allow us to run commands. So if we go to this definition here, we can see it's going to run the system.exec with our command that we saw earlier in our module that we picked out, or that's used for this RCE. So let's put that into action and run that. So we have our rce.py here that we can run, and we need to supply an rhost, which is going to be the IP address of the box that we want to take over, and we have to supply an lhost, which is going to be our IP address, where we are going to run the server. Then we also have to supply our modules with -f. So that's going to be module.so. So now you can see it starts working. So it sent the slave off command, it accepted a connection, it set the file name, it accepted a connection, it tried to run the payload, and that all worked. And now we have the option, well, do we want an interactive shell or a reverse shell? Now I'm wondering, can I also now connect with netcat and run exploits, like run code like that? So let's get back to our command here, see if that works. So now if we do, let's see, what was it? If we do system.exec, can we get command execution? System.exec ID. And as we can see, yes, we do have command execution now. And that's because we loaded that module from earlier. So we don't even have to use this tool, and we can get a reverse shell like this. So let's see if we can get a reverse shell. So we'll go to a reverse shell sheet, and let's pick this Python one, or no, let's do this. Let's do the Bash one. So that's maybe a little bit more easy and short. So we'll say, okay, IP address is going to be 10.10.0.8, and we'll pick port 1234. So we'll copy this and do a system.exec, and then quote these in here. So then in here we'll do a RL rep of our netcat listener. So we have the up and down arrow keys. We'll start listening, and then we'll see if this will connect to us. We don't seem to get any connection. Does that mean this shell has broken or not? Let's see if we can run ID again. Okay, ID still works. So it seems like this bash one doesn't work. That's fine, because we can also try the Python one, for example. But for this one, we'll have to / these quotes, and same here, change the IP address, / these, and we'll also run this as Python 3, since Python 2 isn't a thing anymore. Oh, that's not what I wanted to do. I wanted to do an RL rep here, and then we can do system.exec and see if that works. And that does work, and now we have a shell here as redis. So now we can quit this, and we can upgrade the shell. So I'm going to use my toolkit, which I've shown in different videos. You can find that on GitHub by searching for ctf-bash-tools. So now we can upgrade this to bash with pty. We can then do Ctrl-Z, do an sct-raw-echo, foreground it, then export shell. Oh, this is not going good. Export shell equals bash, export term equals xterm -256 color. Okay, and now we have a decent shell where I can do Ctrl-L and stuff like that. So now what do we want to do here? We want to start enumerating so you can run linp, stuff like that. And I'm going to run pspy here, which is a spy program for processes. So we can look at that in GitHub here. So if you go to pspy, and actually I'll first upload it and start running it, and then I'll show it. So I have it saved in /opt/pspy. So if I do an ls here, you have pspy 64. We can open our Python HTTP server on port 80, and we can then do a wget of our IP address, and then pspy 64. So that's going to download. We'll then have to add execute permissions to this file. So +x on pspy 64, and we can then run that file. So pspy is gonna listen for any command that gets executed, and it's gonna show us, okay, these commands get executed. So it's gonna monitor Linux processes You can get it from here, download the statically compiled versions already, so you don't have to compile it yourself. And it's a great tool. So right here we can already see it's doing stuff. Let's make this big. You can see before every command the UID of who ran it and the PID, the process ID of the process that's running. So pretty much what we're looking for is for some commands that might seem odd, that might seem interesting, with for example the root UID or the UID of a different user. So this is all our stuff. And then here we have some commands as root. So we have this /bin bash of var log redis log-manager.sh. So root is going to execute that. And this is interesting because this is something that seems to be a part of Redis, and we're the Redis user, so we might have some permissions over this folder here. So I'm gonna quit this. Oh, and that killed my shell, which is not nice. Okay, so I've got my shell back as Redis here. So now we can take a look at that cd var log redis. So we can look here, and we had this log manager file that was executed as root. So if we cat this, we see, okay, it's going to execute bin bash. It's going to go through every file in the logs directory here. So every file. And it's going to execute every file and send the error contents to dev/null. So if we have control over this logs folder, which we, oh, my shell broke again. That's not nice. Okay, so I have control back over my shell. So now, if we do an ls-lh here, we can see that over this logs directory, we have write permissions. And we know that any file we put here will be executed by log manager. So we can maybe put a reverse shell in there. So let's go to this logs directory and let's start making a reverse shell here. So we can do bin bash. So we're gonna put our shebang line here, so the interpreter knows how to execute this, or it knows which interpreter to use rather. Then we can specify our reverse shell, and for that we are going to go back to our trustworthy Python reverse shell that we have used in the past. So let's quickly prepare this. So we want to again \these because we are in an echo here. Okay, and then say 1010.0.8 \this one and run this as Python 3. Okay, copy that. You can put that in there, end it with a quote and put it in a file called shell. We then have to say, okay, this shell has to be executable for everyone. So add the execute bit to it. Then we have to do a listener, so netcat-lmvp 1, 2, 3, 4. So now this is something that could, for example, fail for various different reasons. Maybe there's no Python 3, maybe something weird happens that we don't really control. Maybe the server can't make outgoing connections, who knows what. So we'll also, oh, we already got it, but what I would do here is get another one going where we are going to just echo a into like /temp/b so that if this executes and you do an ls/temp, when that executes you should see a file b here. So if this wouldn't return anything, you would still know, okay, the file was at least executed because we see that new file. But in our case it worked straight away, which is perfect, and we see that we now have a shell as root. So I hope you enjoyed this video. I tried to explain and go a bit in depth in the vulnerability. I don't know if you guys liked that. If you did, make sure I know it. If you have any questions, as always, leave them down below in the comments, and I would like to see you back for another video. Take care.